Welcome to today's deep dive. Have you ever been in an airport running late and the boarding announcement sounds like it's being broadcast underwater? We've all been there.
Oh, absolutely.
Yeah. So today we're looking at a product spec sheet from HDTVSupply for the QSC AD-S402T-BK. It's a 2.75-inch columnar surface mount loudspeaker. Our mission here is to just cut through the dense audio jargon, and figure out how this little black box fights acoustic chaos to become this unsung hero of public communication.
Right, because the absolute primary goal of this specific piece of equipment is preserving vocal intelligibility. I mean, it's not built to make your favorite playlist sound amazing.
So no thumping club bass.
Exactly. It's engineered specifically to make sure humans can understand other humans in environments like courthouses, transit terminals, lecture halls, massive spaces made of glass and concrete that naturally just bounce sound everywhere.
So it's basically the anti-concert speaker.
Yeah, pretty much.
The specs note, it's a passive, full-range speaker housing four 2.75-inch treated paper cone woofers. But wait, why stack four small speakers in a vertical column instead of just, using one bigger speaker?
Well, stacking them physically changes how the sound travels through the air. If you use one standard speaker, it acts like a bare light bulb.
Yeah.
It just scatters audio energy in every direction.
Up to the high ceilings, down to the hard tile floors.
Right. And that scattered sound bouncing back at you is what creates that muddy underwater echo.
Ah.
By stacking the woofers in a column, the physical interference between the speakers actually flattens the sound wave.
Oh, wow. So it acts more like a laser pointer.
Precisely. It focuses the audio energy into a tight horizontal beam directed right at your ears.
That makes total sense for indoor acoustics. But these are also deployed on, freezing train platforms and in dusty warehouses.
They definitely take a beating out there.
Yeah. The spec sheet mentions an IP54 rating, a powder-coated aluminum housing, and weather-treated cones. So it resists dust and water splashes. But wait, I'm looking at the frequency range here, 110 hertz to 20 kilohertz.
Oh, yeah, that cutoff.
110 hertz is pretty high for a cutoff, right? I mean, a standard subwoofer goes way lower. Aren't they robbing the speaker of power by doing that?
Well, they are intentionally starving it of low-end power, and honestly, that is the genius of it. Deep bass wavelengths are massive. They roll around a cavernous room and instantly drown out higher frequencies.
They just muddy everything up.
Exactly. So by cutting off at 110 hertz, the speaker naturally strips away all the rumble and boom, it leaves only the crisp, articulate range of human consonants and vowels.
And to make sure that crisp speech actually hits the listener, the specs mention this proprietary PTT network.
Right. Progressive taper topology.
Yeah, which essentially means there is an internal circuit tweaking the signal going to each of the four woofers. It acts like an acoustic lens to steer that sound exactly where the crowd is standing.
Exactly. You limit the bass so it doesn't get muddy, and then you use that PTT network and the columnar layout to aim the remaining voice frequencies precisely where they need to go.
So we have a speaker that cuts out the bass, survives a rainstorm, and focuses sound like a laser.
It's quite the piece of engineering.
It is, but that doesn't really solve the logistical nightmare of physically wiring an entire airport concourse. I mean, physically putting it up is easy enough. It comes with a quick hang pan and tilt bracket, only weighs 7.5 pounds.
Super light, yeah. And the price sits at about $465.
Right. But electrically, the sheet highlights 70 and 100-volt transformers. How does high voltage help you wire a transit terminal?
Well, think about it like this. If you used standard home stereo wiring for a mile-long airport, the signal would completely die of electrical resistance before it even reached the second speaker down the hall.
Oh, just from the sheer distance.
Yeah. By using those internal transformers to bump the audio signal up to 70 or 100 volts, the electrical current actually drops. And less current means less friction and signal loss in the wire.
Wait, really?
Yeah, it's the exact same physics used in long-distance power lines. They use ultra-high voltage to travel miles across the country without losing energy.
Oh, I see. So that high voltage allows venues to daisy-chain dozens of these speakers together on a single amplifier.
Yep, across massive distances.
Without the audio getting weak at the end of the line.
It allows for flawless scalability. When you step back and look at the engineering, you realize this unassuming 7.5-pound box is a highly specialized tool dedicated entirely to public clarity.
So next time you hear a crystal clear announcement in a chaotic train station, you'll know there's likely a rugged device, something exactly like this QSC speaker working overtime to cut through the noise.
Absolutely.
Which leaves you with this to mull over. If this one specific device is designed purely to defeat the acoustic chaos of crowded terminals and courthouses, how much of our daily stress and confusion in public spaces is actually just a byproduct of bad audio design that we simply accept as normal?